to our small query solving session of community dentistry. We come to our next query. Our next query was, what is Fisher's test? Time for a brush up again. Now we know that the data which we gather from a research is of two types, the qualitative data and the quantitative data. If we have the data in qualitative terms, this qualitative data is a nominal scale data and they are called as categorical variables. And whenever we have categorical data, we express these data in the form of contingency tables, which are called as cross tabulation or cross tab. So we make a table. On one side we write the categories and on the other side we write the frequency. So we get a contingency table, and whenever we have to apply a statistical test for such kind of table, we apply two types of statistical test. Either we apply the chi-square test or the Fisher's test. So our chi-square test, it is applied in the contingency table and it is used to check the difference between the expected and the observed results. And the chi-square test, the formula says like this. It is a summation of observed frequency minus the expected frequency, square of them divided by the expected frequency. How do we understand that? We take an example. I'll not go into the details of the calculation, but at least we'll see how we'll apply the formula. In a family where parent could produce children of any blood group, the number of children in each blood group are A is 26, B is 31, AB is 39 and O is 24. So what are these? These are the observed results. What were our expected results? We come back to the question again. So if we see these observed results and we add up all children over here, we get the total population of 120. Now next we just take this chart, and this chart will help us in applying the chi-square formula, and we have the observed results. What were our expected results? What was our question? Our question was, the parents could produce children of any blood group. That is, there are 4 blood groups and there was equal possibility of producing children of any blood group. So the possibility was 1:1:1:1, and our total population was 120. So if we have equal possibilities, that means parents should have produced 30 children in A blood group, 30 in B and 30 in AB and 30 in O. So these were our expected frequencies. Now what we do is we apply the chi-square formula. We get a chi-square value. Then we check the chi-square value in a table. Now this was a chi-square, but our main question we have deviated slightly from our main question. We have deviated because it is important to understand the chi-square test before we go in and find out what is Fisher's test. Why do we need Fisher's test if chi-square test can be done to analyze the contingency table? Our chi-square test, the problem with a chi-square test is it gives errors in the result when the sample size are small. In such a scenario, we go in for Fisher's test. And one more problem with chi-square test is the p-value what we get, the probability value what we get in the chi-square test is approximate, because our table will not give us the exact value. It gives us a near value, and because of this approximation there are always chances of error, and so Fisher's test is usually a replacement for the chi-square test. And the usual rule of thumb for deciding whether we are doing a chi-square test or a Fisher's test is that if the expected value in any of the cell is below 5, we go in for a Fisher's test. And if we have degree of freedom as 1, that is, if we have only 2x2 table, then we apply the Fisher's test if our expected value in any of the cell is below 10. So normally if it is below 5 or if it is below 10 in 1 degree of freedom, we apply the Fisher's test. Our next query, what is Yates correction? And we have been talking about that chi-square test gives us approximate p-value. It does not give us the actual or the exact p-value. So the Yates correction was proposed to reduce this approximation or this error in the chi-square test, and the formula suggested was done by subtracting 0.5 from the difference between each observed value and its expected value, and especially it was more appropriately applied in 2x2 contingency table. As we know that chi-square, it gives more errors in 2x2 contingency tables, so Yates correction was more applied in such tables. But if we have the Fisher's test as alternative, probably the Yates correction will not be needed. There was one more problem with the Yates correction, that it was used for correcting the error in the chi-square, but what it did was over-corrected it, and it gave us the error on, you can say, the other side. So the effect of Yates correction was to prevent the overestimation of statistical significance in the small data. So again, Yates correction is applied when at least one of the cell of the table has an expected count smaller than 5. It's the same scenario which we use to apply the Fisher's test. So don't get confused. We can use Fisher's test as an alternative, or we can apply the Yates correction, but the problem with the Yates correction is that it may tend to over-correct. All these points have been asked in MCQs, so just try to understand what they mean. So herein we have covered few of the very important queries of community net history, and we'll be dealing with the rest of the queries in upcoming sessions. Thank you.